Hello guys, I am so sorry for the super delay of this video for yesterday and today's lesson. Um, so this week we have been doing rewriting expressions using radicals or using rational exponents. So today we are doing using radicals. Okay, so let me review real quick just the general rule. If we have x to the a over b, okay, and I want to rewrite it as an radical. Remember, the outside number always goes like a small letter or a small number or letter on the outside, and then we put the root there. Then we put the x to the whatever power is up there. If there's no number, you don't put anything, but if there is a number, you put it up there. Okay, so let me color code it real quick. So it looks like that. Okay, so that's what you're gonna do today. Let me do a few questions, and this actually day 3 is gonna be pretty short notes wise. Okay, so if I have a to the 2/3, b to the 1/3, and c to the 5/3, you notice that all three of them have a 3 at the bottom. Okay, if they don't, you gotta find the lowest common denominator, which is which number multiple do they have in common. Okay, so all of them, since they all have 3's in common, I'm gonna extract out a 1/3. That means I will be left with a to the second power, b to the first power, and c to the fifth power. Okay, and now we're gonna rewrite it as a root now. So I'm gonna put the root, put the little 3 on the outside, and just write everything inside the root. So a to the second power, b, remember we don't put the 1 because it's invisible, and c to the fifth power. That's your answer. Okay, let's do one more example. Okay, let's do x plus 3 to the 2/5 power. Okay, because the exponent is already out there, we can actually just take out the 1/5 and leave the x plus 3 parentheses to the second power inside. And we're going to finish this by putting the root, and remember, fifth power or fifth root goes outside, and we're just going to leave everything inside with a square. Okay. Let's look at, let me see, should we do a homework question? Yeah, let's do, no, you know what? Before homework question, I'm going to show one more example because this is pretty similar to your homework. So I'm going to have an x to the 1/2, y to the 3/4, and z to the 1/4. Okay, so like now, not all three of them have the same common denominator. So I gotta see what's the LCM. The LCM from 2, 4, and 4 is 4. Okay, so how do I make x exponents to be a 4 at the bottom? We gotta multiply by 2 to the 2 over 2, so we'll make it 2 over 4. Okay, and then the y would be to the 3/4 still, and z to the 1/4. So now that they all have the common denominator, I can extract that 1/4 out. And then keeping x to the second power, y to the third power, z to the first power. Okay, final answer. We write it fourth root of x squared y third over z. That's it. Okay, let me go to your homework page and let's do number 8. Number 8 looks the most complicated one. So I have 2, 2/3, 1/3, and 4/3. If I gotta put a common denominator, it would be a 3 at the bottom. Okay, oops, u 4/3. So how do I make a 2? What do I do to the 2 so I can have a 3 at the bottom? I would want to multiply 3 over 3, so which make it 6 over 3. Okay, and then we're so close to getting our answer. It would be r to the 6th power s squared over t, oop, we don't put that anything there because it's a 1, u to the 4th power. And then we put our roots with a 3 on the outside. Okay. I think you should be able to do the rest of the questions on your own. So finish it, and I'm gonna move on to day 4. Okay, day 4 is a little bit more complicated, but I think you'll be fine. So from day 2, you were doing something that looked like this. You were given the roots, okay, with the like let's say cube roots, square roots, any of that, and then we rewrite it as exponents. So I'm just gonna rewrite what's inside and put that 1/3 on the outside. Okay, your final answer here would be r to the 5/3 s to the 2/3 all over 3 t to the 3 over 3 and u to the 4 over 3. If there's anything that we can simplify, simplify it. So our final answer would be r to the 5/3 s 2/3 all over t u to the 4/3. Okay, that's your final answer. That's only if most of them are their exponents are fractions, but we're going to be working with something that requires an absolute value symbols. Okay, let me write some notes here real quick. So to extract a variable from a radical, sometimes you would see an expression that's in this format, like an n root of x to the nth power. This can be written as follows. Okay, I'm going to write it right here. Nth root of x to the nth power. There's two ways of writing this. Either it's in absolute value or it's just the x. Okay, because you know the n and the 1 over n, it will get canceled out. Okay, if we need that absolute value, that's when n is even. And then when n is odd, we don't need that absolute value. Okay, let me show an example real quick. So if I have 6 root of x to the 6th power, if we want to rewrite it, remember how it's usually x to the 6th power to the 1/6. Those 6 and 1/6 get canceled out. We're left with an x, right? But then since the outside is an even power, like this number right here, since this is even, then we would need the absolute value bar right there. Okay? That just means that if I'm gonna ever like substitute a number into x, if it ever turns into like a let's say like a 6, or actually I don't know what's a good number to pick. Let's say this is 5. I can put a 5 inside the root right here. The number is still good, okay? If I put a number that's a negative number, and then I put roots of -5, this is not possible. It's not possible to have a negative number inside an even root. Okay, so that's why we really need the absolute value bar to get rid of this problem. Okay, so if I have a 5th root of x to the 5th power, That means it's going to be x fifth to the 1/5. And then those 5 and 1/5 get canceled out. We're left with just an x. Okay, and since this is odd, it equals to x only. We don't need that absolute value bar. Okay? Okay, let me continue. So here's an scenario right here. If I have, let's say, square root of x squared, okay? This is gonna be x square root of x squared. The square and the square root get canceled out. That means we're with just x. Okay, so do we need the absolute value in this case? Yes, we do, because this is a second power. This is an even power. Even though it's invisible, it's still even, so we need the absolute value right there. Okay, and then if I do square root of x to the 4th power, okay, this would be x squared. Okay, let me just show real quick why. Because it's x to the 4th to the 1/2, right? So it will be x squared. So do we need the absolute value bar? So this is still correct, writing it in absolute value of x squared, but oops, it's not necessary to include the absolute value bar. The absolute value symbol, because x squared is non-negative. Okay, because if I put a 5 in there, 5 squared gives you 25. If I put a negative 5 in there, when I put square, it also gives you positive 25. So either way, if I put it back into my roots, if I take this whole thing and put it back into my roots, it still generates positive answers. So therefore, it can leave it as square root of x to the 4th, that's x squared. Okay. Let me show some example to make this a little bit more clear. I have square root of m to the 4th over n6. Okay, so do the same thing. I'm still going to keep my inside in a parentheses, and outside exponents, we're going to put 1/2, right? So again, since this is a invisible 2 and that's even, we know we would possibly need to put the absolute value bar there. Okay, so this equals to m squared over n to the 3rd, right? So which one doesn't have a even exponents? Those are the ones that we're gonna definitely put absolute value bars on them. So it's the bottom one, because this is even and that's odd. Okay, let's do another one. Let's do cube root of m to the 3rd power over n to the 6th power. We write 1/3 m third over n to the 6th power. Okay, so if I put the 1/3 into each of them, I have m to the 1, which is invisible, over n to the 2nd power. Okay, since this number right here is odd, I don't need to do any absolute value. That's already my answer. Okay, let's do one that's a little bit more complicated ones. So I have a square root of 25a squared b c to the 10th power. Okay, so if I do 25a squared b8 c10 to the 1/2, okay, because it's a 2, so make sure we put absolute value for something. What's square root of 25? It's just a 5. Okay, and then now we're going to put as 1/2 into each of those. We have a to the first power, invisible, b to the fourth power, and c to the fifth power. Okay, so the ones that need absolute values are my odd degrees, which is this one and this one. Okay, so if you want to make it look nicer, it would be 5, absolute value of a c to the fifth power, and then our b to the fourth power would just be left outside. Okie dokie. All right, let me show you some homework questions. Let's do number 3. So number 3, it's a odd degree or odd root. We have x minus 2 to the 6th power to the 1/3, right? So 6 times 1/3 is going to give you 2. And again, since this is odd, we can just leave our answer as it is. Okay, let's do number 6. Number 6, what's the root right here? It's invisible too, right? Because it's a square root, and that's even. So I'm going to do a 1/2 out here, 36z to the fourth power. 36, it's really 6 square, right? So let me just show that step real quick. The 2 and the 1/2 goes away, so I'm left with the 6, z to the second power. Okay, do we have any odd degrees here for my final answer? No, if there's no odd degree, that's already your answer. Okay. One last one. I will do number 10. Number 10 is a even degree, even root. So let's do 16x to the 12th power, y fourth, z to the 16th to the 1/4. Okay, so 16, we gotta break it down. It's 82, 42, 22. Circle all your prime numbers. Do we have any groups? Obviously, it's 2 to the 4th power, right? So I'm going to write the rest to the 1/4. Almost done. I got 2 to the, remember 1/4 goes into each of them. So 2 to the first power, which we don't write, x to the third power, y to the 4 divided by 4 is 1, so we don't write that power again, and then z to the fourth power. Okay, since this is an even degree, we got to put our absolute value bars to the odd ones. So third power is odd, and just the y is the odd. So we got to absolute value bar those two terms. And then this is your final answer. Okay, make sure you guys get this page done for your homework. And then for your Friday assignments, it's a quiz, and I will grade it as a quiz. So make sure you get it done and upload it. And because I gave you guys all of these this lesson very, very late, you guys can turn in these 3 assignments on Tuesday at what day is that? Let me see. I think it's 4:28. Okay, so just turn that into Google Classroom. All right. Okay, let me know if you have any more questions. Have a good day. Bye.